across the scientific community and beyond. The planet, while fascinating due to its massive size and unique location, also displays mysterious lights that appear to be artificial. This could be the breakthrough that transforms our understanding of the universe as we know it. Are we on the verge of uncovering the secrets of extraterrestrial life? By exploring NASA's amazing findings, we may soon learn the truth about these mysterious lights and what they mean for the future of space exploration. The journey to this discovery begins back in 2007 when NASA launched the Dawn spacecraft on a mission to explore some of the most captivating objects in our solar system. Equipped with 3 ion engines, Dawn was designed to embark on a groundbreaking journey, starting with an in-depth 14-month study of Vesta, the second largest asteroid in the asteroid belt. The spacecraft sent back a wealth of detailed images and data, revealing Vesta's complex surface and rich geological history. As the mission at Vesta came to a close, Dawn embarked on the second part of its journey, one that would capture the attention of scientists and the world alike. With its powerful ion engines, Dawn was able to leave Vesta's orbit and head toward its next target, the dwarf planet Ceres. Unlike traditional chemical propulsion systems, these ion engines provided a gentle, continuous thrust, allowing the spacecraft to travel great distances and ultimately enter a stable orbit around Ceres. This advanced technology made it possible for Dawn to reach its destination with unmatched precision. Discovered in 1801 by the Italian astronomer Giuseppe Piazzi, Ceres is the largest object in the asteroid belt that lies between Mars and Jupiter. For many years, Ceres was thought to be the smallest dwarf planet in our solar system, a status it maintained until its reclassification in 2006. With a diameter of about 950 kilometers, Ceres is the largest and most massive body in the asteroid belt, and one of the most intriguing. Its unique characteristics have made it a subject of great interest to scientists, who have long speculated about what secrets it might hold. As Dawn approached Ceres, the anticipation grew. The spacecraft was about to send back the first ever close-up images of this mysterious world. The Dawn mission's primary objective was to improve our understanding of the solar system's formation, particularly the role of water in the creation of planetary bodies. Among the most striking features observed on Ceres were mysterious bright spots, especially concentrated in a large crater known as a crater. These bright spots were unlike anything scientists had seen before. Prior to Dawn's mission, Ceres had only been seen as a blurry, low-resolution image taken by the Hubble Space Telescope. But now, with Dawn's close-up, the mystery deepened. Could these bright spots be a sign of something far more complex? The bright spots on Ceres immediately sparked intense speculation. Some scientists believed they might be composed of highly reflective materials, such as salts left behind by sublimated water. This discovery suggested the possibility of cryovolcanism, an unusual type of volcanic activity in which instead of molten rock, materials like water, ammonia, or methane are expelled from below the surface. Could Ceres be home to active ice volcanoes? What could these bright spots really be? Were they signs of ongoing geological activity, or were they something even more extraordinary? These questions, once thought unanswerable, were suddenly within reach. Ceres is unlike other bodies in the asteroid belt. Its size, mass, and potential to contain water and ice set it apart. Unlike the typically rocky asteroids around it, Ceres has a composition more similar to a comet, which led scientists to believe it might offer valuable insights into the early solar system. After 2 years of travel, the Dawn spacecraft finally reached Ceres in early 2015, marking an important milestone in space exploration. As Dawn drew closer, the images of Ceres became increasingly detailed, unveiling a world that had long been shrouded in mystery. The first images revealed a surface riddled with craters, each a reminder of Ceres' long history of impacts. However, what truly captivated scientists and space enthusiasts alike were the bright spots, scattered across the dark, rocky terrain. As the spacecraft's resolution improved, more questions emerged. Were these spots patches of ice reflecting sunlight, or could they be something even more exotic? The scientific community formulated several theories, ranging from the presence of mineral deposits to the possibility of cryovolcanic activity. After closer inspection, it became clear that the brightest of these spots was not a single entity, but rather a cluster of multiple distinct spots, each with its own unique characteristics. The most widely accepted hypothesis is that these bright spots are deposits of salt, left behind by the sublimation of water. This finding suggested that Ceres, contrary to previous assumptions, may still have some form of geological activity capable of bringing water or brine to the surface. When water or brine reaches the surface, it quickly evaporates, leaving behind bright, reflective residues. This discovery painted a far more dynamic and complex picture of Ceres than scientists had previously imagined. Could the presence of groundwater or brine pockets mean that Ceres could support life, or at least provide valuable clues about the potential for life elsewhere in the solar system? Ceres, often described as an icy world with a porous rocky surface, has a unique composition compared to its asteroid neighbors. Its surface is made up of a mixture of water, ice and hydrated minerals, including clays and carbonates. This composition makes Ceres less dense than the rocky asteroids around it, suggesting it holds a significant amount of water beneath its surface. Its surface is rocky yet porous, with ice and other volatile substances trapped inside. This makes it more like a comet than a typical asteroid. Scientists believe that Ceres has a distinct internal structure, consisting of a rocky mantle, and a core rich in water ice. This core accounts for about 50% of Ceres' total volume. The mantle is thought to be a mixture of rock and brine, surrounding a core that may be made up of denser materials such as silicates. The presence of water ice suggests that Ceres may have once hosted liquid water, especially if its core was heated by radioactive decay in its early history. This insight into Ceres' internal structure has sparked new questions about its potential for geological activity. Could it still have pockets of liquid water beneath the surface? Could these pockets be a source of the mysterious bright spots? Even more exciting, the discovery of ammonia clays on Ceres suggests that the dwarf planet may have formed in a cooler region of the solar system before migrating inward. The presence of ammonia may lower the freezing point of water, supporting the idea that surface brines could exist. These findings not only enhance our understanding of Ceres, but they also provide valuable clues about the processes that govern the evolution of icy bodies throughout the solar system. Cryovolcanism, an intriguing and rare form of volcanic activity, adds another layer of mystery to Ceres. Unlike traditional volcanoes that erupt molten rock, cryovolcanoes expel materials such as water, ammonia, or methane. These substances can exist as liquids or gases in extremely cold environments. On Ceres, cryovolcanoes could be responsible for the bright spots observed on its surface. The most famous of these bright spots is located in the Akata crater, known as Spot 5. This area has garnered much attention due to its high reflectivity, and periodic changes observed by dawn. Scientists believe that the bright spots are caused by water sublimation, suggesting that cryovolcanic activity may still be occurring, or may have occurred relatively recently. In addition to Spot 5, there are several other bright spots, scattered across Ceres, each with its own unique characteristics. These spots are not confined to one region, but are spread across the surface, which indicates that cryovolcanism could be a widespread phenomenon on Ceres. This challenges previous assumptions that the dwarf planet was geologically inactive and presents the possibility that Ceres is more dynamic and active than we ever imagined. As dawn continued to send back more detailed images, a variety of surface features began to emerge. Ceres' surface is covered with craters, ridges, and cracks, each telling the story of its geological history. With every new discovery, our understanding of this distant world grows deeper, opening up new questions about the history of the solar system and the potential for life beyond Earth. Let me know what you think in the comments below. If you enjoyed the video, don't forget to like and subscribe for more updates.